In this video, I'm going to discuss one-point perspective, and it's all in the art instruction course on Amazon. The picture plane is a transparent vertical plane between the viewer and the scene beyond. Think of a window as your picture plane. Use a marker and draw tracings on it of the patio and the lake and the trees that we see outside. If the lines on the scene are parallel to the edges of the window, they are true horizontal and vertical lines. If the lines are not parallel to the picture plane, they are diagonals. The station point is where the viewer's eye is in space. The viewer looks at the scene through her cone of vision, which forms a 60-degree angle with her eye. We usually limit the extent of the cone of vision so it doesn't include our peripheral vision, where things become blurry. And to test this, extend your arms sideways while looking straight ahead. As you move your hands forward, keeping your elbows locked, you won't be able to see your hands clearly until they enter your cone of vision. And with linear perspective, instead of becoming blurry, objects lying outside this cone of vision become distorted. The line of sight lies at the center of this cone. It intersects the picture plane at our center of vision, which lies in the middle of our field of vision. When we look straight ahead, this center of vision lies on the eye level. This is not true when we look up or down. Let's look at one-point perspective, here a railroad track converging toward a vanishing point, and determine what we can say about it. First of all, these converging rails, since they go to the same vanishing point, these rails must be parallel. Since this vanishing point is on eye level, these rails must be parallel to the ground. And then finally, the horizontal ties and the vertical poles are both perpendicular to these converging rails. The look of perspective is ingrained in us. Some optical illusions exploit this, so we misinterpret the sizes of elements in the image. In A, the upper horizontal line looks longer than the lower one, even though they're the same length. In B, the upper box appears larger than the lower one, even though they're the same size. In both cases, we expect objects high on the page within converging lines to be smaller than those lower on the page in accordance with perspective. In C, the top line appears the longest even though they're all the same length because its converging lines are the most spread out, so we expect it to be the smallest. These are pictures of tiles where I get closer to the ground with each photo. I kept the bottom red line the same length in each case. In the overhead view, the tiles are the same size and the sides are parallel, so there's no vanishing point. In number 2, the converging lines meet at a vanishing point at eye level, and when I get closer to the ground, eye level also goes down. The tiles resemble trapezoids, where their tops and bottoms are parallel and their sides are converging. They flatten with distance because their vertical length going into the distance gets smaller than their width. In other words, the distance direction foreshortens. The spaces between the tiles in number 1 are the same size, but they get increasingly narrow in 2 and 3. To draw a box in one-point perspective, start with this yellow square and connect each corner to a vanishing point on eye level. Then draw the back part of the box so that the corresponding corners touch the same converging lines as the yellow square, so this left upper corner and this left upper corner are connected. The front and back are in actuality the same size since they lie within the same converging lines. Finish the box by solidifying the converging lines between the front and the back. If you move a square horizontally away from these converging lines, it would be the same size as the one within these lines. If you move this square up like here, assuming it's not a substantial move, the square would appear to be above or below the original square rather than receding in the distance. This permits the artist to place an object with the correct size anywhere in the image using only one set of converging lines. The three sides of the box are usually seen in the bird's eye view and less commonly in the worm's eye view. Here are some boxes that you would want to avoid. Avoid having only two sides visible since it's not as informative as three sides, and that occurs when the box is directly underneath the vanishing point, when the box straddles eye level, or when one side lines up with the converging line. Perspective is distorted if the box is too close to the vanishing point, causing the distant part to taper quickly. If the box is far away from the vanishing point, it could appear too elongated. The artist always can intentionally distort perspective, however, to add drama and tension. If the front and back sides of a box coincide, it looks like a hexagon because that's a simpler interpretation than a 3D cube. So you would want to avoid that. Also avoid a symmetric trapezoid, which looks like a two-dimensional shape. An asymmetric trapezoid better indicates depth. A structure with diverging sides, like a bay window, shows four sides, and although we don't interpret this as a cube, it better indicates volume than a converging structure with only two sides visible. If the vanishing point isn't in the picture, the eye may follow the converging lines to the edge and out of the image, which isn't great. So have a counterbalancing line that lures the eye down the road, keeping it in the picture. And the asymmetry adds interest, while the high vanishing point emphasizes the street. A low vanishing point encourages the viewer to look up. If the street were a dead end, the viewer may feel like he should stay away. Instead, it should continue beyond our view to add mystery. Wouldn't you rather walk down this street than this street? In this case, my grandson in red here is near the end of the converging lines. Although we generally don't want a straight eye path going directly into the focus, it seems to fit this simple scene. Here are some examples of one-point perspective. These are buildings from overhead, and these are buildings from the side. A table and jar here both converge toward different vanishing points on eye level. A common mistake is to show too much of the table so it appears to slant toward us. Curves in a stream become smaller and flatter with distance. In my next video, I'll describe some advanced topics in one-point perspective, and please remember to subscribe.